Hello, everyone. Thanks for joining this session. This is the last session of the day. For this session, we have Assistant Professor Tis de Kock. He's an assistant professor at University of Washington Foster School of Business. He studied the combination of computer sciences and capital markets research. Today, his presentation is about prompt engineering and large language models. So please welcome Tis.
Good afternoon, everybody. Thank you for that introduction. I guess there's no need for me to repeat the title, but I'll say it anyways for the sake of the recording. Welcome to my session, Going Beyond ChatGPT, an introduction to prompt engineering and large language models. My name is Tis, and I'm, as Jorge said, I'm a professor at the Foster School of Business. Specifically, I am a special breed of professor. Specifically, let me make sure this works. Turn this on. Yes, specifically, I'm a professor in accounting, which there's not many of us, but we do exist. And I imagine whenever I say professor in accounting, there probably are more questions than there are answers with regards to why I'm here presenting this session today. So I'll kind of introduce what we're going to do first, but then second, I'll give you a little bit of a background, a little bit of a peek into what I do on a day-to-day basis, which hopefully will give a little bit more kind of explanation, a little bit more backstory on why I'm so interested in large language models, machine learning, natural language processing, data, and all of those good things. Okay, so what I want to do today, the basic premise of this tutorial / session for the next 85 minutes or so, is I want to talk a little bit about how we can use models such as ChatGPT, which I'll generally refer to as generative large language models. How can we do these to kind of help do our data science work? Okay. Now that is super broad, and that's super broad because, well, I do not know exactly what all of your backgrounds are. I'm an academic. Some of you might be academics. Many of you probably are not academics. And you probably want to use models, techniques for all sorts of applications. But the reason I submitted this, the proposal for this task was actually reasonably simple, where what I noticed was a lot of people have used ChatGPT for things. I mean, I would go by the assumption that most of you probably have or are aware of it or have at least used it at some point, right? Maybe you've used it to help with coding. Maybe you've asked it coding questions. Maybe you've asked it to write an email. Or maybe you asked it to write a report, or maybe you asked it to proofread something, or maybe you asked it to give you a joke. This particular joke, by the way, took me about 8 tries to get one that was halfway decent. All the other ones were absolutely terrible. And I'm like, that's not really in the spirit of what I'm trying to say here. So there was a little bit of human kind of engineering involved before I ended up with this one. But what I've noticed is that most people, and myself for a long time included, like you kind of use these things and you can copy paste things into the web interface. But very often that's kind of the end of it. Right? You're not really doing much beyond it. And maybe you have, and in that case, hopefully there's still some nuggets here. But primarily the idea is, well, what can we do besides just copy pasting things into the web interface? Right? What else can we use this for in kind of a data science context? And also, if we start doing that, how can we do that programmatically? Right? Because that's the whole point. We don't want to copy paste anymore. So that's what we're going to do today. I want to kind of give you the tools that you can, so that you can kind of implement it for your own problems, so that you can write a little Python script to feed things into ChatGPT and then get it back and do something with it or do whatever with it that you want. Okay? And then the other thing is hopefully by the end of it, you'll have a little bit of a better idea of what you can do with these types of tools. Okay? They're not magical, like they have their limitations, but there's a lot of cool things that you can do, and hopefully by the end of this, you'll have a little bit of a sense of what that is. Okay. Also, before I forget, the way I'll do questions is I'll occasionally just kind of open it up, and I'll take a few questions, take a little bit of a break, and then we'll kind of move on. I have a little bit of a few slides, but then we'll jump into the notebook, and we'll spend most of our time in the notebook just running through some code, and you can follow along. The instructions for that will follow in a moment, but questions will come, or the opportunity for questions will come. Yeah? Okay, so that's what we'll do. Now, the reason why I'm so interested in this is, I would say, twofold. One, the thing I do on a day-to-day basis is I'm a tenure-track professor. I do research. I get evaluated on primarily my publications. So I spend most of my time behind a Jupyter notebook running code. That really is the majority of my work. Okay. Specifically, what I do is my expertise is in textual analysis and machine learning to analyze company behavior in capital markets. Okay. Typically not something you would think of when you think of accounting. You might think more about like bookkeeping or just numbers. But companies disclose a lot of narrative, a lot of text too. If you've ever opened up an annual report, there's more text than there is numbers. So my research expertise is I analyze that text. Okay? That can be an annual report, that can be social media messages, that can be earnings calls. Whatever a company puts out in the world could be a subject of interest for my type of research. Okay? And for that, I use a lot of textual analysis techniques. I use a lot of machine learning. So I spend a lot of time thinking about that for my day-to-day work. Okay? And in terms of teaching, what I do is I teach Python to our PhD students, and I teach accounting analytics to our undergraduate students. Okay? So I also spend a lot of time thinking about how can I make these tools more approachable, because I enjoy using it, but honestly, I get a lot of kind of rewards out of just talking about it, like telling people the cool things that we can do, and then I learn from that in return as well. Okay. And I have some work on this too, where last year, kind of April 2022, way before ChatGPT was a thing, I was using these models already because, I mean, there's a long history of these GPT models. I say long, maybe 2 to 3 years maximum, kind of starting with GPT-2. And I had started to use these models for different types of textual analysis problems because they're really powerful. I wrote a blog post about it last year saying, hey, this is a cool thing. You can do a lot of cool things with it. Got maybe a little bit of traction, but for the most part, it was kind of niche. But then ChatGPT happened, and everyone, including my mom, knows about what this is. So there's like a huge kind of a little bit of a snowball effect going on. So I recently wrote, and recently means I only put it on like the public-facing website yesterday, so very, very recent. I wrote a little article, a paper to talk about the application of these types of models for academic research. But, I mean, running a textual analysis problem in academia is basically the same as running it in practice, so I consider that to be broadly applicable. Those two links are there if you want to look at them later. I'll refer back to them occasionally, but this entire session will be standalone, but I'll kind of point out and say, hey, you want more details? Go watch here, or go look here. Yeah. So that's a little bit my background. And I submitted this session just because I thought, hey, I have never done a PyData session before. I find it really cool. I'd be happy to talk about it. So I submitted it. Here we are. Yeah. Okay. So very briefly, what will we do? I have a few slides. I think I have about 5, 6 slides that I quickly want to walk through to give you a little bit of an understanding about what generative large language models are. Okay, I know this is a tutorial. We want to get to the code, and we'll get there, and we'll get there real soon. But I don't know kind of what your background is. And some of you might have a lot of experience with these models. Others might have just played around with the web interface a little bit, and that's it. Okay, so I want to make sure that I don't lose people at the very beginning. So I just want to kind of say a little bit of like, this is what it is, this is how it works, and then we'll jump into the code. Yeah? Then we'll spend most of our time on a little deep dive example where we'll start automating something using the OpenAI API, so we can programmatically interact with ChatGPT. And then I'll conclude with a little bit of a demonstration of LangChain, which is a Python library that allows you to do some more fancy things with large language models. Depending on how quickly we go through the material, that might be a quick like a list of cool things we can do. If we have more time, I have all the code examples in the notebook, and then we can go through that too. Yeah. All the materials for today are on a GitHub repository, or are in a GitHub repository. You don't have to open it up right now, but at some point I recommend to just make sure you have that open somewhere, because that's where the notebook materials are, that's where the slides are. All the links that I have in here, I have those links copied in the GitHub repository too, so you don't have to go painstakingly type those over. Just click on the link in the GitHub repository. And then that's kind of all there, but I'll show that link a few more times. Yep. Okay, so I'm an accountant, so I love disclaimers. That's all we do. We're really good with disclaimers. So 3 super quick disclaimers. 1, this space moves extremely fast. It's very possible that what I'm talking about today is going to be somewhat out of date in 2 weeks. It is just how it is. When I submitted this proposal in February, which is not that long ago, GPT-4 was not a thing. ChatGPT API was not a thing. The Meta Llama model, the semi-open source model that is very, very popular, not announced. Same thing with the Stanford alpaca data set, wasn't a thing. So when I kind of submitted this proposal, I had something else in mind where I'm like, oh, you want to use ChatGPT automatically? How can you do it? Then the ChatGPT API came out and I'm like, well, that idea doesn't make any sense anymore. So then I pivoted, so we're just going to look at the ChatGPT API, right? Kind of makes sense. I tried to make everything somewhat future-proof, but it's hard to do because I don't have a crystal ball. I do not know what the future is going to look like. But hopefully, even if things change, it's still going to be helpful, what we'll discuss today. Yeah? It's also not going to be comprehensive. I'm just going to focus on a few things that I have experience with that I think are easy to get started with, but within 90 minutes, we can simply not cover everything. And the other caveat, and that's the middle one, is I'm an academic. I don't have to ever take anything into production. Like getting stuff into production can be a real pain as far as I understand. My wife's a data scientist. She talks about it all the time. I just need to get it to run once, and then my job is over, okay? So that means that I'm not going to talk about taking these things into production. Some of these things you might be like, ooh, that would be a real pain. I feel sorry for you, but that's not a problem I deal with on a daily basis, so I cannot speak to it, okay? Okay, so with that caveat out of the way, I'll pause here for a quick second so you can open this up. And I want you to open it up specifically to do one thing that you might have to do while I'm kind of going through these slides here, which is you don't have to install anything. You can just, like, there's a button there, the launch binder button. Click on that. It should spin up a little instance. Everything's there. You don't have to install anything. You can just run it. Okay, so all the things I'm going to do today, you can follow along there. The one thing that you do need to do, and this is one of those things where if I would know in advance what I was going to do, I would have put this on the website, but I didn't. I only really made this session a few days ago because that's how we do things as professors. We are never that prepared, is that there is one thing you need to do, which is you will need an OpenAI API key if you want to run everything, because we're going to be interacting with these models through the OpenAI API, which requires an API key. The notebook has like 3 steps that you need to do to get that. You don't necessarily have to get it if you want to just kind of follow along by just reading it, but if you want to run it, you will need that key. So if you don't have one already, I would recommend just go there. The one thing I will say is that that key, if someone else has that key, they can run things on your account and charge your credit card if you have that hooked up in the process. So you want to be a little bit mindful of that key. Just kind of treat it as a password. What you can do if you're a little bit worried about whoever's sitting behind you spying on your API key, they're really long, so they have to be real super fast to copy that. You can just create one for this session and then just delete it afterwards. You can create multiple at once, just create one, use it, and then delete it if you're paranoid. Okay? I'm paranoid, so that's what I do. The session we used today, I'm just going to delete it, then I don't have to worry about it. Okay? And the other thing is, because these are paid services, if you don't have an account yet, they have about a $5 credit that you can use. The amount of credits that we're going to be used to run the entire notebook today is, I think, like 80 cents. So it's really not that big of a deal. If you already have been playing around with this and you ran out of credits, then you will need to make sure there's a payment method, otherwise it's going to give you an error. Yeah? But again, it's an optional thing. Yeah? Okay, so make sure you kind of have that ready if you want to follow along once we get there in about, let's say, 5 to 10 minutes. While I get some of these kind of introduction things out of the way. Okay, I'll try to get this, or try to go through this somewhat quickly just because we want to get to the code, and then I also want to have a little bit of time to open it up for any questions before we jump into the notebook. Okay, so a few basics, right? What is a generative large language model? A generative large language model, very simple. It is a model that takes text, spits out text as a result. That's the simplest definition I can give you. That's how I think about it. Okay? So the way that works, we give it a little bit of text, that one on the left where it says prompt. That's generally how we refer to that. The prompt goes into a big model. There's a lot of them out there. The most popular one, or the most well-known one, is ChatGPT, but there's other ones too. And then what it does is it spits out some more text. Okay? That text we generally call the completion. Yeah? Now, I did put a little asterisk there on the input text because there is a lot of developments going on to make this multimodal, which means you can not only give it text, you can also give it images or audio or whatever, which I think if you think of kind of like images, that has tremendous potential too, but there's no publicly available, well, there is some kind of like experimental stuff, but there's no kind of production ready model out there that you can currently use for that. So it will probably take 2 weeks before that is there, but it's not there right now. So I'm not going to talk about it. I'm just going to pretend that doesn't exist, but keep an eye out for it because I think it's real cool. And the way that this would kind of work is think of it as in the world of ChatGPT. You would give it an input. In this case, I would say, hey, tell me a joke that the Python crowd would find interesting. That goes into the model. The model will start to predict token by token. A token is just a part of a word, basically, what it expects to come after that. Okay, it's just kind of like a super powerful autocomplete, if you will. Yeah? So in this case, it could be like, okay, well, it starts with Y and then did and then the and then blah, 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 until it does the whole joke. Yeah? And then at some point, it realizes it's done, which is kind of an interesting mechanic. I won't go into this, or I won't go into detail, but just know at some point it realizes I'm done, and then that's it. Okay. Now, at first glance, this is useful for a chatbot, right? I mean, if you think about it, kind of like a Q&A style thing, this makes a lot of sense. You give it a thing, it responds back with text, all's good with the world. But this actually has a lot of applications, more so than you would initially think, at least more so than I originally thought, specifically because this kind of approach has two favorable features. One, everything happens through text, which is kind of unwieldy in the first kind of beginning if you've ever done machine learning, because you're not used to like if I have a machine learning problem, I'm not defining it through text, like I define it through some type of algorithm or something, right? But here everything happens through text, which is actually very, very flexible, as you'll see in a moment. And the second benefit is that because these are so large and they're generally purpose trained, they can handle a lot of tasks without much training. Like if you ask ChatGPT to do a thing, or especially GPT-4, which is more powerful, it can, you can ask it a task and it will just kind of do it. Like if I give it a piece of text and I ask it, does this text talk about programming? It will probably say yes or no. Like I don't have to train it to do that. It just kind of knows what programming is and it's able to answer that question. Okay. That last bit of you don't have to give it any training, that's really where the innovation of ChatGPT is. Okay, ChatGPT versus all the other GPTs. The ChatGPT model is what we call an instruct-tuned model, which is it's specifically trained to be really good at doing what you want it to do without you having to give it examples. Okay, but the model itself is kind of the same. Yeah? Now, the primary benefit from a practical point of view, from a data science perspective or an academic perspective or a researcher perspective, I guess, is that you can use these models as an alternative for doing things manually or doing things using complicated machine learning algorithms. At least that's what I use them for. That's what they substitute in my workflow. Okay? They're not as good as people. I mean, it's always better to have a person do a thing, but in many cases it gets really, really close. And the benefit is it's a machine, so I can have it do a million things and it's not going to complain. Right? If I have a person, they get hungry, they get tired, they get cranky, the model will just do it for me. It will never complain, which is really beneficial. Yeah? Okay, so what we'll do in the example today is these things are best to just illustrate. So the working example that we are going to work through, and I try to come up with an example that seemed reasonably practical and non-academic, because my academic examples are not really that exciting necessarily. So if this feels close to home, then I did a good job. If it doesn't, I'm sorry, I'm an academic. I just try to infer what people actually are doing in real life. So let's say that we're data scientists, right? And we work at a company, and the company has a mobile app. Okay. And this mobile app, it has a little bit of an issue, and people have been complaining that it's too slow. Let's say that's our problem. Okay. Now, we have some magicians, some developers, and they've implemented a fix. Okay. They're like, we fixed it. Like, the lag is gone. The responsiveness should be great now. And then management comes to us and they say, well, hey, go verify that actually worked. Go check. Go make sure that people are not complaining about something being unresponsive anymore. Okay? So what we do is we pull up a little SQL database, or we have a bunch of JSON files or whatever text files that just has all of our customer complaints. Everything submitted through the app. Okay, you just can imagine in the app, there's a little button that says, hey, there's a problem, you want to submit some feedback, you click on it, you can add a little message, right? And these messages can look like, it's annoying when the app takes so long to process a payment, the app could benefit from a better recommendation system, yada, yada. Okay, but the key thing is, what we're interested in is we want to know which ones of these talk about performance issues and which ones don't. So that we can put it in a little pandas data frame, create a little graph, and basically say, hey, number of complaints that talk about performance went up or down or was the same. Yeah? But before we can do that, we have to kind of get past this point of having a bunch of text. Yeah? So that's what we'll do. We'll just kind of build a little pipeline using the ChatGPT API to go automatically classify these as being related to performance issues, yes or no. Yeah? And what this substitutes for is we could do it manually or we could outsource it, which outsourcing is essentially just doing it manually, but you're not the one doing it manually, right? Someone is doing it manually. Or we could develop some natural language processing approach, or maybe develop some type of machine learning. Okay. Now, for many tasks, doing either of these is going to be slow, time-consuming, and/or expensive. If you've ever dealt with text, you might have experienced this. I experience this on a daily basis, so I internalize this very much. If you don't do a lot of work with text, then maybe this doesn't ring as close to home. But just believe me, it can get real difficult. Yeah? This example, not a good example of where this is necessary, because you can probably just create a little, like a keyword list or something where you say, hey, if it mentions unresponsive, I classify it as being a performance issue or not. But let's just pretend that this is a problem that we cannot solve easily otherwise. Okay? I could have picked a more realistic example, but if I pick a more realistic example, I'm going to spend 30 minutes trying to get you up to speed on what the example is, and that's not the point for today. Okay? So we'll just kind of, like, let's say we've made the cost-benefit trade-off and we want to go use the GLM to do this. Yeah? Okay, so the way we're going to do this is we're going to develop a little prompt, which is this thing over here. Maybe you cannot see the pointer, but that thing on the left, which is just a piece of text that says, does the feedback mention a performance issue? Then we're going to put in a little feedback text, and we're going to ask it to return it in JSON. Okay, there's nothing special about this, just a piece of text. Okay, this, like developing that thing on the left, that's what we call prompt engineering. Engineering the prompt. I put engineering in air quotes because if you ever spend any time on Hacker News, people get really hung up on the term whether this is engineering or not. Some people are like, oh, this is definitely engineering. Like, this is such a valuable skill. And other people are like, this is people saying that they're good at Googling. Kind of a fair point. I mean, like, that's not really a thing you put on your CV these days. But people do currently put on their CV that they're really good with prompts. And I think people are, or companies are hiring people that are good at it. Whether that will stick or not, I do not know. But right now you have to play around with it a little bit to get that to work. Yeah? And then what will happen is it go through this thing and it will give a piece of text back. In this case, answer equals 0, and then we can load that back into Python and do with it whatever we want to do. Okay, so that's what we'll kind of implement with a little bit more detail. And then in order to do that, we have to kind of do some steps, which I won't go through this in too much detail. My paper goes in this in painstaking details. There's many pages of details, so if you want, go read that. But basically, we need to go figure out, do we just want to ask it to do this, or do we want to give it some examples? Maybe we need to do a little bit of training. Okay, like there's some steps involved there. We're going to be in the world of everything just works. It's called zero shot. It just works out of the box. That doesn't always happen. Very often, that's not the case. You might have to do some fine tuning. You might have to train it. That's out of scope for today. There's resources out there if you want. Then we'll develop our prompt. Right? We somehow tell it how we want to, like what we want it to do. We give it some instruction. We give it the text, and we ask it, go do this thing. This prompt engineering, I have a lot of resources on it. They're all on the GitHub page, but basically the high-level takeaway here is that interacting with these models, it's a weird mix of talking to a person and talking to a machine. It's really unnerving at times because on the one hand, you're just talking like you're talking to a human, like, can you please do this? I catch myself asking please, or including please all the time, where I'm like, can you please do this? I'm like, why am I, like, what is this? Like, I'm afraid that they're going to take over the world and they'll spare me because I was nice to them or something. Like, I don't know, but it's just human nature, right? It's hard to kind of, or it's easy to kind of forget that you're talking to a machine. But it is important to keep that in mind because sometimes you ask it to do a thing and a person would never get confused. But the model, it might have no clue what you want it to do, which is straight over its head, okay? The same thing here, like in this example, like I can ask it to return JSON. If I ask a normal person to go like a research assistant and ask it to give me this in JSON, they're going to give me a blank stare. Or they're going to be like, I have no clue, right? That's going to be super tedious. The model doesn't care. Curly brace equal to the model as an A. Like any character is basically the same thing, right? So we kind of have to figure out a way to talk to it that's kind of like human-like, but at the same time also not. And that's the whole kind of art of prompt engineering. Sometimes people call it AI whisperers. You somehow have to get it to do what you want, and it's a kind of more of a trial and error, if anything. Yeah? And then finally, we want to make sure that it actually works. I'm an academic. This is what I get grilled on all the time. So, but I think in practice it's super important too. You want to make sure that it works, right? I mean, it's easy to just assume, hey, these are powerful, everything will work, but that's very often not the case. You got to check, got to make sure it does actually do the thing I want it to do. Okay, I have some tips here. I won't go through these, but this, like, you can look at this later. If you want to go do this, here are some tips to get the prompt to work. We'll kind of refer back to some of these every so often. The paper goes into more detail. Just know there's a lot of things you can do to have more of a success whenever you develop a prompt. Yeah, it's a little bit dry material, so we'll just pretend that slide's not here, but you can use it as reference material. Yeah? Okay, so let's see. How are we doing on time here? Okay, good. So I'll open it up for a few questions, if there are any, before we jump into the notebook, and then we'll kind of dive into those materials, if there are any questions, anything you want me to go into before we get into the code. I'm a teacher. I spend a lot of time teaching on Zoom, and if there's one thing I know, on Zoom I have to wait at least a few minutes, but there's a question in the back. Yes? Yeah, so I'll repeat the question for the recording or for the microphone. The question is prompt engineering simpler for GPT-4 than it is for ChatGPT or GPT 3.5 Turbo or whatever it's called in the API? I would say generally speaking, yes. I would say generally speaking, the GPT-4, which is the more powerful model, it will be able to do what you want without you having to baby it as much. But at the same time, there still is prompt engineering involved even with the GPT-4. But for the most part, it does tend to work much better. And I've noticed, at least using just the interface, if I can do something with GPT-4, that generally works much better. The thing is, it is extremely slow and extremely expensive. So for what we're going to do today, very often it's just not really a viable option. It's like many, many magnitudes more expensive. So trade-offs. Yes? Mm-hmm.
That would be nice for some kind of feature extraction.
Sure.
And it's kind of okay, and then we just write name question mark.
Uh-huh.
And it's just much better.
Yes.
You know, like I say, you restrict what you actually want, and you don't go so much into it. Like, can you say something about this kind of thing?
Yeah.
Because I mean, yeah,
Uh-huh.
there is kind of like this switching to talking to a machine, even already in the earlier part, you can only just give me JSON.
Right. Yeah. So the question kind of relates to sometimes you give it kind of a human instruction, it gets really confused, and then you add something, and then all of a sudden it starts working. I've noticed the exact same behavior. Now, why that is exactly happening, I think the most honest explanation I can give you, and I mean, if there are machine learning people in the crowd, they might disagree, but I think we're currently at a stage where we generally don't really understand exactly how these things work. So I cannot claim to say, kind of to know exactly why that works. But the thing I would say, as kind of more of a practical takeaway, is that I've noticed, and I've interacted with these a lot, also at scale, is that small things in the prompt can make a huge difference in the ultimate outcome. And that can be, like adding something can make a big difference, but also sometimes just taking something away can make a huge difference. Like I used to have another kind of a use case, and I wanted them to, I think it was like I was trying to classify Twitter messages or something along those lines, and I had the word may in there. Like it's like may relate to something. The model just, like all over the place, high variance. I remove the word may, and I just say relates to, and all of a sudden it starts to kind of do what I wanted to do. So for some reason, that one word, that one token, just threw the entire model off. I wouldn't be able to tell you why, but the key takeaway is, I guess, you want to play around with this. And sometimes taking things away can be useful. Sometimes just super bluntly say, this is exactly what I want can help. But it's more of an art than a science. Does that help? Yeah? Okay. Yeah, in the back. GPT or ChatGPT to create its own prompt. There are developments or experiments currently happening that try to do this. And I think for a lot of people that say being good at building prompts is kind of like being good at Googling, it's kind of like their argument usually is this is a temporary thing, but eventually the tool is going to get real good at helping you write those prompts, or the tool is just going to get so good at understanding what you want that it ultimately doesn't matter. I have tried this, and I've had mixed results. For the most part, for academic reasons, and I think this applies more generally for all problems, very often you have a very specific thing you wanted to do, and it's very hard to communicate to the model what you want the prompt exactly to do. So then you're kind of back into, you're trying to prompt it to create the prompt, and then you might as well just create the first prompt in the first place, if that makes any sense. So that's kind of my experience. But there are people that kind of swear by just having the model create the prompt for itself and then just kind of use it. So I'd say use it as inspiration, but I wouldn't blindly rely on it. Yeah, but it is kind of an interesting development. Yeah. Okay, good. So I think this is a good point to talk about like 30 minutes or so to kind of set the stage here. So for the remaining time, I just want to get our hands dirty and talk a little bit about like how does this look like in code, okay? Now, I'll open this up just in case you haven't been able to pull it up if you want to follow along. I have this repository. It's very easy to get to. If you don't want to type this whole thing out, just search my name. It's easy to find. And what I have in this repository is, I think, reasonably straightforward. The slides are here if you want to look at it. We have this notebook right here. And there is some other, like there's an environment file if you want to download this locally. I don't recommend you do that now because it will take a little bit of time to download all of that. But if you want to, at a later point, recreate this environment, you can. But for now, the only thing you really have to do is just click this Launch Binder button. I don't need it, but it opens up this. And then it will take a little bit of time to kind of load. But then once you do, it should just pop you straight into a Jupyter lab where you can run your code. Okay, it just kind of set everything up automatically. Yeah. As you can see, super fast. Okay. Let me see, what did I break? Just get rid of this. Okay, I think this just... There we are. Okay. Now, make sure this is large enough for all of you to see. Is this legible enough? Yeah? Okay, good. This notebook, really, really, really long. There's a lot of stuff in here. We're not going to be able to go through everything in painstaking detail. We just don't have the time for it. Plus, I mean, if I were to do that, it would get a really kind of tiring 90 minutes, which they're already pretty long. So I'll just kind of skip over a few things. I'll kind of highlight the things that I think are kind of interesting. I'll also stop occasionally to kind of ask, hey, did anyone have any questions, anything you want me to talk a little bit more about? But essentially what we'll do is we'll start off by replicating that problem with the feedback messages for the app to try to identify the ones that relate to performance issues and the ones that do not. And then after that, I have, I think, about 3 or 4 different examples that go, or that use the LangChain library to do all sorts of cool stuff. But the cool stuff, it gets complicated real fast. So I'll kind of take a little bit of a higher level approach to those. But I do want to take a little bit more, or go into a little bit more detail for the API, just because I think that's where the real power is. Like if you can kind of do that, then like the world is your oyster, basically. The LangChain stuff might be useful, but for many of you probably is less useful than just being able to interact with the API. So that's what we'll focus on. If you're familiar with APIs, this is probably going to be a breeze. If you're not that familiar with APIs, or using APIs or interacting with APIs using Python, some of this might be a little bit more new. But I'll kind of take it slow, and again, if you kind of get confused or you get lost at some point, once I open it up for questions, just let me know. Okay. I'd rather take it slow and go through less material than to just race through everything and then kind of lose everyone along the way. Okay. Okay. So what we want to do is we just want to load this up, and then hopefully I did everything right, and I can just load this. In terms of packages, in case you're kind of curious. There isn't really too much exotic stuff going on here. The only packages that we really are going to use is the OpenAI package. But the OpenAI package is super basic. It's basically just a wrapper around requests. So if you ever do any API calls using requests, you can do this using requests directly too. Really not that big of a difference, but the OpenAI library just makes it ever so slightly more convenient. Okay. So that's what we use. And then these other kind of the tick token one we'll just use to get a little bit of a sense of how expensive it's going to be. And the LangChain is for all the kind of more complicated examples later. Yep. And then we'll borrow a little bit from the scikit-learn library too, so that we can do a little bit of evaluation just like we would with any other machine learning approach. Okay. Okay, so we can kind of run this. This is just a bunch of stuff. Doesn't really matter. This little section here is I'll uncomment it, but you don't necessarily have to do that, is that particularly the LangChain library, it does a lot of things, and it can be really opaque what it's actually doing. I find it very helpful to just be able to see what requests it's actually making to the API, so I know exactly what it's doing, which is not super obvious most of the time. So I wrote a little bit of code, a little bit of script. It's not super pretty, but it does work, that essentially logs all the requests to the OpenAI server and just stores it into a file. So I can just look at the file and say, hey, these were all the requests that were being made. We won't need this for the first bit because we're going to be making the requests, so we know what's in there. But later on, once we get to these more complicated packages, it just does a lot of stuff, and it's kind of hard to keep track. So I'll show you what it's actually doing in terms of requests so you can follow along a little more easily. But I didn't debug this very well, so it might very well not work on your computer. Okay, so I know it works on mine, so I'm happy to run it. But in your case, you can just kind of leave these commented out or play around with it if you want. I mean, you do you. But in my case, it does kind of work, but that's what that is. Yep. Okay, and then here, this is where the steps are to get the OpenAI key. If you want it, you can just follow those. You can put that in here. In my case, I have it stored as an environment variable, so it just pulls it from there. For all these kind of secrets, generally being able to store it in a file or store it in your kind of environment variables, probably a good idea. You don't want to just have this in your notebook, right? I mean, if you, like, there's a lot of cases where companies, and this same thing applies for like AWS or Azure or whatever keys, if you put them somewhere on GitHub and people get access to that, they can just start charging on your account. Same thing here with OpenAI. Okay, so you want to kind of treat this with a little bit of caution. And don't come running to me and say, hey, after your session, someone racked up a $1,000 bill on my account. I told you so. Okay? So in this case, I already have it set up. If you don't, it will prompt up a little thing. You can copy it in, and then you should be okay. Yep. Okay, and then what we'll do is we have a little bit of data, because we need to work with a little bit of data. Specifically, the data we'll work with is, for this first example, we'll just use 20 examples of app feedback. It's a very small sample, but just makes things much easier. And then for the other examples, we'll use some data that I'll talk about later. Yeah. Specifically, I just scraped all the talks that we'll have at this conference, and we'll build a little bit of a recommendation system using GLM, using LangChain, to predict what talks might be interesting to a certain individual. Okay, so we'll use that later. For now, not super important. And the same thing for this Excel sheet. Yeah. The last example that I have is we'll allow the language model to actually execute Python code and just control pandas data frames directly. It's a terrible idea, but just for the sake of demonstration, I'll show you how to do it. Okay, but we'll do that at the end. And for that, we need a little Excel sheet, so that's what this is. Yeah. Also, in case you're wondering, this is just a thing that I only recently figured out I could do, but I thought it was really cool, is I have a little function here. I won't dwell on this for too long, but if you work a lot in Jupyter Notebooks, this might be useful. This one right here, this little function allows you to just print things in Markdown and have it render in a notebook. I do not know why that gives me so much joy, but it gives me a lot of joy because I can do things like this. And I know there are ways to do this in notebooks too, but it's just a little fiddly. I find this easier, where I can just have it print something and just like put something in bold. That's what this is. Like the 64 is just like an F string, right? But I do the M print instead of print, and it just renders it nicely. Completely unnecessary, but at the same time, it's one of those joys in life. Okay, at least it is for me. But maybe I'm just weird. Yeah? Okay, so let's run through this example right here, which is to automate this problem using the OpenAI API. Yeah? Now, the data that we work with, just to kind of give you an idea, is we have a little data frame here where we have, like, this is very simple. We have a little index so we can keep track of it. We have the message. I mean, I generated the messages using GPT-4, so they're not really realistic necessarily, but it just makes things easier. I couldn't even be bothered to generate 20 examples. That should tell you how lazy I am, but it worked really well. I just asked it, hey, give me 20 examples of this, and it just did it, right? I mean, save myself a little bit of time. And then I also asked it to classify it at the same time while it was generating it. So again, don't read too much into it, but just gives us something to work with. Okay. So we have our little message that we want to classify as in relates to performance issues or not. And we have our little column that says this relates to performance issues so that we can evaluate it. Right? Which that evaluation is kind of important, because if we do not have some type of gold standard here, or like a sample of truth, we have no way of knowing whether it will work. And we want it to work, so we have to be critical of it and like have something to check. Okay, so we'll kind of feed these predictions through, and then we'll compare it with that column to see whether it worked, yes or no. Okay. And then we can kind of look at what these look like, which we could have here, for example, a piece of feedback that just says, hey, navigating the app feels sluggish at times, especially when scrolling through large lists. We could have, please add a feature to create and share wish lists with friends and family. The creativity of GPT-4 is unmatched. Or the app is too slow to load images, which makes it hard to browse products efficiently. Otherwise, it's a great app. Okay? Good. Right? We have 20 of these. We could easily do this manually. But let's say that we have 1,000 or 10,000 of these, and we just want to be able to automate this and do it automatically. Okay, so this is where the real magic happens, and it has very little to do with coding, but this is where you're going to spend hours or days or whatever it is to kind of get this to work. Sometimes it works real quickly. It's just a matter of a few minutes. Sometimes this can just be really frustrating. But we have to figure out a prompt. And that's really, for the most part, that's really all we have to do. We have to just figure out how we can ask ChatGPT to do this task and do this task consistently. Okay? So what I did here is and you can do this just using string formatting in Python. You don't have to do any kind of special things. There are special libraries for this, but honestly, it's really not that complicated. You just create a sentence with placeholders using curly brackets, and we're just going to slot values in as we generate our predictions. Okay? So what we have here is we have our little prompt, the prompt template. It's a template because the actual message is not in there yet. Right? We're going to just slot the different messages in here as we run it. And we're going to ask it, identify whether the customer feedback text below mentions performance issues. And then I can scroll it up a little bit so you can see the whole thing. With our app, answer using the following JSON format. And then I give it a little bit of a format. And then I give it the feedback text. I give it the index so I can keep track of it. I give it the message. And then I tell it JSON equals. And then we're basically just going to give it to the model, and we say, hey, figure out what should come next. Okay. Now, when I wrote this, I went back and forth on this a few times to kind of get it to kind of behave. Like, this usually doesn't work out of the box. Okay, so a few things that I kind of realized as I was developing it. One, I realized that having JSON equals at the end is just generally a good idea. It just makes it behave much more consistently. If I don't have that, sometimes it just goes off and does a thing. Like, sometimes it just says yes. I'm like, no, I don't want you to say yes. I want you to say 1 or 0. But by forcing it to go into JSON, it's like, oh, this JSON format here, that probably has to go here. It makes it much easier to predict what should come next. Okay. But again, I didn't know this at first. I just kind of play around with it. So I usually do this. The same thing, the order matters. Like, I could put this message in the very beginning, and then I say, classify the message that came first. But that very often doesn't work as well, just because it reads it left to right. So it just reads some random thing that I cannot control. And then it reads my instructions, but then it reads my instructions conditional on the actual feedback thing. And then from one feedback to the next, it might figure out that it needs to do a different thing. Okay? It's more of an art than a science. There's a little bit of black magic too, but this is where you just want to play around with it. Okay? The good thing is, you can play around with this all day long. Like, if you want to work with RAs, or like research assistants, which I sometimes have to do, I have to ask very nicely, can you please try again? With this, I don't have to ask anyone. I just ram a bunch of API calls in there, and it just does the thing. Right? I have to pay a little bit of money, but as we'll see later, this will cost like a fraction of a cent. Like, it's really, really cheap. Okay. So what we have here is we have a little template, okay, and we can give this template to the API call, and I'll kind of show you how that works. We do this, like, for example, we take a little example. Oh no, okay, I need to run this. Where, again, as you see here, like, there's nothing special about this, right? I just use the format command in Python to just like swap in the variables. And then we get a prompt that looks like this. where the thing that gets swapped out is the index gets swapped out. You can't see that, but that's right here, and we get a little message. Okay, and this, we can copy paste this straight into the ChatGPT web interface. That's essentially what we're going to do, but we're just going to do it through the API. It's actually a very powerful way to debug. Just take this, copy paste it into the web interface, and just play around with it there. It's exactly the same model. There's some asterisks there, but for the most part, exactly the same model. Okay. Okay. Let me see. I think I'll just kind of take a quick pause here because I think the prompt, like that's really where the magic happens. The rest is just a little bit of nitty gritty. How do we send this into the API? How do we get it back? But does anyone have any kind of thoughts, questions on kind of this particular prompt or anything like that? It's totally fine if it's clear, but. Yes. Right, yeah, so the question is, I didn't put quotations around kind of the actual feedback thing, which kind of makes sense for people, but to a computer, like if you try to do that in an actual code, it's not gonna work, right? Like we need to delineate it as this is a string, otherwise it's gonna get really confused. Interestingly, the quotes can make a difference for these types of prompts because it can help the model understand where it starts and where it ends. But I kind of sidestep that problem a little bit by just adding an enter, by adding a new line character here. And the new line character is what makes it kind of separate out where it starts and ends. If I wouldn't do that, sometimes it might get confused about where the feedback starts or ends. So generally speaking, you want to do something to make it obvious where it starts and where it ends. But in this case, I sidestepped it by doing the quotes. And very often, because you pay these models by the token, that's just like they generate tokens one by one, and you pay for every token. You don't pay a lot per token, but still, it scales up. So what you want to do is if something is not necessary, it's generally a good idea to get rid of it because it just makes things ever so slightly faster and it makes things ever so slightly cheaper. So that's why I didn't do it here. But I think you could do it and it probably would work equally well. Yeah?
So just a comment in here. So when you are running these queries, you already know the value of I. So therefore, you don't really need to send I in this message. And if you wanted to minimize the number of tokens that you use, you would also even like try to make it not reply with a JSON, but rather like in this case it's binary. So you say reply only with 1 or 0 if blah 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 blah.
Yes.
Like to set the example.
Right.
It's not what you would do if you would scale it for actually.
Yeah, great point. So the point being made is that I have some redundancy here that I probably could get kind of rid of to kind of save on some tokens. Specifically, this whole I equals business, maybe that's not necessary. And the same thing with the JSON equals. Maybe if I just ask it to return 1 or 0, it probably will be just fine. In many cases, in particular, if you give it some examples or if you fine tune it, I would 100% do it that way. The thing I have noticed, and I'm an academic, like I nitpick over accuracy just because that's kind of what my life is that I did notice in this case, if I do this, it will cost a little bit more tokens, but it gives me two kind of peace of mind things that sometimes are worth it and sometimes they're not. Which one, I like having the I there because sometimes when you send these things, it can be a little tricky to match it back up to the original data set. If you code it up diligently, not an issue. But this way, I can just save it in a file, and I can just like completely blindly open the file back up, and I know, oh, that was I, so that one, so I can match it up. So that's kind of why I do it, because it makes it easier to match. A little bit of redundancy. The JSON one, it just eliminates any chance that it starts doing anything else, which for the 0 shot, sometimes it does. If you fine tune it or if you give it examples, not a concern, because you just basically force it to think that way, and it's always going to do exactly what you want. But I agree with you, if I was really concerned about tokens, I would just not have it do any of that, just give 1 or 0, and it probably would work just fine. Yeah. Yes?
On the web interface, it remembers the conversation. Is there a way on the API to give it instructions once, and then we send a message and reply back?
Yeah, so that's an interesting point. So the point bringing up is if you are in the ChatGPT interface, right, you can have a conversation with it. Like you can have it, and then you could follow up with it multiple times. That doesn't exist in the API. But the thing is, like if you think, or the way that the ChatGPT app works, like the web interface, is it does nothing else. Like it doesn't have a memory either. It just builds a new prompt every time where it includes your previous conversation as part of the prompt. So you can have a memory through this too if you want. Like I can have it do this thing, have a generation, and then I can do a follow-up. I just have to create a new prompt where I add its own kind of message as part of the prompt that I give it for the second kind of communication. So you can build in memory, but these are all independent predictions. And also with the ChatGPT interface, exactly the same thing. They're all independent. It's just that it starts building up the prompt as you go along to make it aware of what the past looked like. Like they don't have state, if you will.
Let me add here that the API does have, so the OpenAI has a chat API, which kind of does these that you're saying, like building that prompt.
Yeah.
But you can send like individual messages via JSON, and you can have like a system role and a user role.
Right.
In this case, you would like generate this JSON.
Yeah.
And augment it with the response. So you would get like user, and it would be your prompt, assistant, it would be OpenAI's response, and then you would grow this JSON and invoke the API.
Right.
So you can have that conversation.
Yes. Yeah, and I have an example of that in a moment, but still, it's still doing the thing where it puts it all in a prompt. It just happens on the OpenAI side of things instead of on your side of things. But I like to think of it, it's easiest to think of it as it's just building one big prompt somewhere, because that's ultimately what it's doing, makes it easier to kind of understand why it sometimes works and sometimes does not. Yeah? Okay, yes, I'll take that quick question and then I'll show you how to run it. Yeah?
His remark on the confirmation marks. So you're assuming here that there's no new line character in your text. Right?
In the feedback? Yeah, so the question is, what if there's a what if there's a new line character inside the feedback? Yes, and that's a good question, and it's actually really interesting because, like, I've been doing natural language processing for many, many years, and like these things matter a lot in traditional methods. Like you just put a wrong character somewhere and everything breaks. It's just how it is. These models have kind of like they have a little bit of kind of foolproofness built into it, where if I were to accidentally have an extra new line in here, most of the time it probably will still work. It just kind of realizes, hey, this probably is all part of the same feedback because of the type of text that it is. What I could do is I could clean it up a little bit beforehand and just make sure there is no new line characters in it before I put it into the prompt. That would be the safe way of doing it, but it's much more redundant than some other methods are just because of what it is. Like it's trained on text on the internet. Text on the internet is not known for being super clean. So it just kind of learned to deal with it. But I wouldn't rely on it for anything important. Yeah, good point. Okay, so what we kind of have our prompt, right? This is where you spend, this is where very often the magic happens. Just figuring out how can I put my task into a prompt and how can I get something back that I can actually use. Usually once you figure that out, there's a little bit of a kind of like a scalability concern and a cost concern, but for the most part, it's not that complicated anymore. Okay, so what we can do is we can do the programmatic equivalent of copy-pasting this into ChatGPT. But before we do that, there is one thing that is kind of useful to think through, which is on the ChatGPT interface, if you don't have a subscription, it's kind of free, right? You just plug it in there and you don't pay for anything. If you have the Plus subscription or whatever, you pay a fixed fee. It doesn't scale variably. Again, accountant, so I think variable cost. If you do this through the API, these are variable cost items, which means the cost scales with the number of tokens that you give it, which for just like a little bit of experimentation doesn't matter. But before you just start hammering this with thousands or 10,000 of calls, you want to do a little bit of math to make sure, hey, this is not going to bankrupt me, right? Because especially if you use the GPT-4 API, you can rack up costs pretty quickly because that's not cheap. ChatGPT API pretty cheap, GPT-4 not. Okay, so I always want to do a little bit of math beforehand to know how much is this going to cost me. Okay, the way we can do that is there's a library called TickToken. It's also by OpenAI, and what this does is it will enable you to essentially convert your little prompt into what kind of GPT will see. It's just like a vector with numbers which represent the different tokens that are in your prompt. Okay, and then because you pay per token, if you have an idea of how many tokens you have, you can calculate roughly how costly it's going to be and also roughly how long it's going to take. Okay, so we can do that. We can create a little encoder that will encode the text to this vector of numbers, which are these representations for the tokens. And if you do that here for this specific example, I can encode this and I can actually just show you what this looks like, because why not? You will see This is what ChatGPT or GPT or whatever will see. Just a vector, just a list of numbers. But these numbers, it has kind of like an internal memory of what these actually represent, and they usually represent in the English language about 4 characters of a word. Okay, so like a short word might be a single token. Like you can look up what the code is for the, for example, like that's just a number. But then if you have a word that consists of multiple words, then, or a little bit of a longer word that consists of multiple tokens, then you might have multiple of these in a row. Okay. There's nothing really you have to do with this, but it is good to realize that that conversion is happening because sometimes it explains why things are a little bit weird. Okay. Also, there's a, if you search OpenAI tokenizer, there's this little web interface. It's not exact because this only is for GPT-3, not GPT 3.5 or GPT-4. But you can put like a little text in here that says whatever. Like if I put this in here, you will see that it will kind of tell me what the tokens are. Now in this case, these are 3 tokens, but depending on what type of model you use, it might be split up sometimes too. Okay, so I can copy in, for example, this whole thing. Again, this is slightly different for the ChatGPT one, but this is more visual. And you will see, like here, for example, the word identify. Like, and these are kind of arbitrary. Like they all kind of use the same tokenizer. I'm not entirely sure. It probably just doesn't matter all that much. But you can see the word identify, for example. It's kind of consistent of like ident, that's like the first token, and then efi is the second token. But like in the world of ChatGPT, the world of GPT, that's 2 kind of different things. It realizes there's a kind of like a white space in between 2, so that has some informational value. But sometimes it does kind of really weird behavior, or sometimes you're like, why does this cost so many tokens? It's just because certain things take up more tokens than others. Okay, like a word can be just like 1 token, like following, but like this whole thing with this JSON thing might be like 5 different tokens because everything is a separate token. Okay, like you can play around with, like once you start scaling it up, you can be like, I'm going to remove white spaces where not necessary because a white space is a token too. Most people are not going to be living in that world, but that's a thing one can do. Okay, so just kind of like that's what's happening, and we pay per token. And specifically here we know, if I just get rid of this, we have about 76 tokens in our prompt. And our completion, which is what it's going to generate, is going to have about 13 tokens. This is where just returning 1 or 0 is going to be a little cheaper, right? Because there's going to be 1 token versus a bunch. And then I can calculate how much that's going to cost by just going to the OpenAI pricing page. There's different APIs too. I'm not affiliated with OpenAI. I'm not paid by OpenAI. Go spend your money wherever you want to spend your money. There's also like the Azure has endpoints for many of these models too. And you can just look up how much it's going to cost. And here, for example, GPT 3.5 Turbo, which is ChatGPT, cost $0.002 for every 1,000 tokens. Okay, so we can do the math. How much is it going to cost me to feed about 20 of these examples through my my little pipeline here? Let's say one of these examples is about 100 tokens. We have about 20 feedback items. Cost per 1,000 is about $0.002. And then we could do a little math here to say running 20 items is going to cost me a whole total of $0.004. Okay, so that's not really going to be that big of a deal. At least I hope it's not, because then you probably have bigger issues. But we can do the math here too, where let's say I need to do this for 100,000. It's all fun and games that I can run 20, right? And even if 20 would cost me $10, and I'm like, oh, I don't care about $10. I mean, if 20 costs $10, scaling it up to 100,000 is going to get real expensive real fast. Okay, so I generally say, think a little bit through how much you're going to need to run, do the math before you commit all this effort into figuring out whether you want to do it, because you can develop a beautiful pipeline. If it's going to be too expensive, it's kind of pointless, right? So it's best to do that math early. So we can do that here. Let's say hypothetically we'd have 100,000 of these. We can do the math, and if we have 100,000, it's going to cost about $20. Okay, having a person do 100,000 of these is going to be more expensive than $20. I would assume. I haven't really outsourced anything overseas, but I would assume it's more expensive than this. Okay, that is everything I have for you today. If you want to know more, I'm always on GitHub. I have a bunch of open source stuff, so you can follow me there. If you want to go into more detail, my paper is a good source. It goes into painstaking detail, so maybe even too much detail. But you can find that on SSRN. It's for free, so you can just go read it if you want. And then with that, we were out of time for questions. I wish you a great rest of the conference, and I'll stick around if you have any more time. And otherwise, have a good evening. Thank you.